Welcome to our quarterly number 1 live stream. We're going to go through Units 1, Unit 2A, and Unit 2B, and just what you'll need to know for this quarterly. Bear with me, I did come down with kind of a cold this weekend, so if I lose my voice or anything, just kind of bear with me. But a really good place to start is making sure that you are hooked up to Remind in some way to me. So if you're in my class, just use my Remind code. If you're not in my class, then right down below me, there's a link to a Remind code that you guys can use, and that will go right to me. I won't ever send you guys messages on that. It's just so you can send me questions as we go. The point of the live stream is, again, that you guys can interact with me live, ask questions, and if you aren't watching live but you're watching later, that's great too. Continue to send me or your teacher questions as you're studying. So, with all that said, let's get started. If at any point you have questions tonight, just send me a message, but we're going to get started. So, first things first is, how do I know what to study? And for that, there's really 3 places you can look. So I would start with your old learning targets. That would be the very first thing I would look at. Review sheets from old units and old tests and quizzes. You have a review sheet for this unit. That's going to be the most specific, obviously. But, any of those are good places to start for more questions. The test is going to cover these 3 units. So Unit 2B, which is all things logs, from graphs to inverses to solving to word problems to converting, all of it. Unit 2A, it's going to focus mostly on laws of exponents, exponential models, and graphs. Can you find domain and range? Can you find asymptotes? All of those things. And Unit 1, we're going to focus on transformations, domain and range, systems, and again, inverses. So you'll see a lot of topics that loop through the 3 subunits, but those will be the big things that we're hitting on tonight. So let's get going with some Unit 1 stuff. And I want to start with inverses because those are sort of a common thread that we have throughout all of the units. So first of all, finding inverses, and most of us are doing pretty well with this. But when you're finding inverses, remember, you are going to switch your x and y, and then you're going to solve for y. And that's really the key. Now, sometimes the algebra in there gets a little messy, but if you know to switch x and y and then start to solve for y, you know the algebra 2 of it, and everything else is algebra 1 that we can, make up along the way. Something to remember about graphs of inverses is that they are reflected over y equals x. Because remember, we said we switch x and y, right? So we are reflecting over y equals x. So what that's going to wind up looking like is, if this is my function, so there's my axes, let's say that's my function, y equals x is this line right here. So that's going to take it and it's going to flip it over that line. So it's going to look something like that. It's going to look like it got flipped. Same thing if we talk about exponentials and logs. So if this is your exponential graph and this is y equals x, then your log graph is going to look like that. So it should look like it got reflected. So that's an important thing to make sure that you remember. And we're going to talk a little bit about exponential versus polynomial, because a lot of times we know what to do. We're just getting stuck in the algebra of what to actually do in there. So with that all said, let's start with some more basic ones. So for this one, I see f of x equals 3x minus 1. Remember that f of x is really just y. So this isn't even switching my x and y. That's just rewriting with y. So then I'm going to switch x and y. And now the algebra 2 is done. Now everything else here is algebra 1. So I'm going to solve this for y. I'm going to add 1 to both sides and divide both sides by 3. Now, instead of writing y equals here, because I started with f, I'm going to do f inverse equals, and you could leave it as x plus 1 over 3, or you could make it 1/3 x plus 1/3. Those are equivalent, right? Leaving it as all over 3 or dividing each part by 3. Let's try this one for g of x. So again, g of x is the same as y, so I'm just rewriting this. And now I'm going to flip my x and y. And now my goal is to get y alone. So again, the algebra 2 is done. Now it's all algebra 1. So I see that the outermost part there is a radical. I'm going to undo that by squaring because it's a square root. So square to undo that. So now I've got x squared equals y minus 3. Add 3 to both sides. And instead of writing y, I'm going to write g inverse equals x squared plus 3. Now, let's go into some that use logs. So, whenever you see ln, something I would just make a mental note of is you know that your base is e. And so now, when I switch my x and y, I'm going to have x equals ln y minus 3. And again, you can continue to write that base of e if that helps you. And what I always have my classes do is put like a rectangle around the log to make sure that it's isolated. So there I have my log, my base, and my argument. It is isolated. And so now I'm going to convert. So e to the x equals y minus 3. Now I'm going to add 3 to both sides. And so here I get g inverse of t, because t was my original variable, equals e to the x plus 3. So the big thing on these is remember that anything that you switch, make sure you switch back in the end. One more with a log. So m of x equals log base 4 of 2x minus 3. So I'm going to make this x equals log base 4 of 2y minus 3. And again, my log is isolated here. There's nothing multiplying or adding with it. So now I'm going to convert. So it's 4 to the x equals 2y minus 3. I'm going to add 3 to both sides. So 4 to the x plus 3 equals 2y. Divide both sides by 2. And this was m, so it's going to be m inverse of x equals 4 to the x plus 3 over 2. Or you could write this as 4 to the x over 2 plus 3 over 2. You cannot, on this problem, reduce that because order of operations, you need to do the exponent before you do any division. So you're not allowed to reduce that there because that would be messing with division before you mess with the exponent, and PEMDAS won't let us do that. All right, let's look at 2 more, and these are the ones people tend to get mixed up. The idea between, is it a polynomial or is it an exponential? So on the one on the left, the t of m, notice that it's m to the 5th power. I can undo raising something to the 5th. If that's to the 5th, when I undo it, it's going to be the 5th root. This is raising something to the x power. I can't undo that using a root. I would be taking the xth root, and I don't really know how to do that. So what we need to differentiate between here is when is it appropriate to use a logarithm and when is it not. And just remember that logs are inverses of exponentials. So on one like this, I'm going to switch my x and y, so x equals y to the 5th plus 2. Now I'm going to solve, so x minus 2 equals y to the 5th. And notice that this is not exponential. It is not a number to an exponent that's unknown. So I can undo raising something to the 5th by taking a 5th root. So 5th root of x minus 2 equals y, or in other words, t inverse of m is the 5th root of m minus 2. So if it's a variable base to a real number power, we don't need to use a logarithm. Now, if I look at this one, where I've got 5 to the x minus 1, I can't take an xth root there. So I'm going to have to deal with this like an exponential function. So this is going to be x equals 5 to the y minus 1. Add 1 to both sides, just like we did before. And now notice that this is isolated. I'm not going to take the yth root because that's alone. So I'm going to convert this. So it would be y equals log base 5 of, make sure you have parentheses around it, x plus 1. And so I would have f inverse of x equals log base 5 of x plus 1. So those are the basics with finding inverses. Again, if you have questions, send them along on Remind, either to my class code or to the code that you guys joined at the beginning of the live stream. Now, last thing we're going to talk about with inverses is the idea of something being invertible or its inverse being a function. So remember we said up here that inverses are reflected over y equals x. And so something that we talk about to determine whether something is a function or not is whether it passes a certain test. So if I look at this and I say, okay, is this a function? You would tell me, yeah, this passes a vertical line test, right? So any vertical line you draw through this, it would only hit your function once. if I look at the reflection of that over y equals x, this would now no longer pass a vertical line test because it would hit more than once, right? So back in Unit 1, we talked about the idea that if we want the inverse to pass a vertical line test, we should check and see if this passes a horizontal line test. This one does not, which means it would not be invertible, or its inverse would not be a function. So for this next part, and again, these are right off your review sheet, but again, it's something important to take a look at. Would these be invertible, or would their inverse still be a function? So what I'm looking at for this is, does it pass the horizontal line test? So this one does not pass a horizontal line test, right? That's not going to work there. So this is a no. This one, would it pass it? Well, if I draw it at any point, and I know here it almost looks like it flattens out, but it doesn't quite. I could actually draw it, and it would only hit once. So this one's a yes. This one's a no. It doesn't pass a vertical line or a horizontal line test. This one's a yes, because right there it doesn't hit twice. This one, still a yes. And here's a funny thing. Let's see if we notice this. This is actually the inverse of this. It's flipped across y equals x. This one right here would be a no. So remember, if I ask you if its inverse is a function or if something is invertible, then just look at the horizontal line test, because that would tell me when I flip it if it would still pass a vertical line test. Okay, we are going to do one of these systems algebraically. If you have trouble with these systems, then go back to my Unit 1 live stream. I have a ton of links in there of different things to help you, but if you have trouble with these, go back and check that out. We're only going to do one of these just for the sake of time. But remember that the hardest part with these is not normally the algebra. It's normally the fact that we're messing up addition, subtraction, multiplication, or division. So just be very careful with that stuff as you go. So I am going to number these for the sake of making this a little easier. I'm going to call that 1, this 2, and this 3. And remember that we're using elimination. So I'm going to choose any 2 and do some elimination here. So I'm going to start, 2 and 3 is pretty obvious that I could eliminate those. So if I do 2 and 3, and these are right off your review sheet, so again, feel free to look at those as you're doing this, but I'm going to leave 2 alone. And I'm going to multiply 3 by -1. So that will make my x's eliminate. And it doesn't matter which variable you eliminate first. Just remember, whatever you eliminate first, you have to eliminate again in your next step. So your x's eliminate here, so this gives you -x, or -y, sorry, plus 1z equals -3. This is my first equation that I'm going to use. It's down to 2 variables. Now, pick either other set of equations. You could do 1 and 3. I'm going to do 1 and 2 just because they're right there in front of me. And so let's take a look at what those were again. So I'm going to leave 1 alone. I'm going to multiply 2 by 5 because that will make my x's cancel again. So 1 was 5x minus 4y plus 2z equals 21. Multiplying by 5 down here, I would get -5 minus 25y plus 30z equals -120. And now I'm going to combine those. And notice I eliminated x before, so I'm eliminating x again now. So here this would give me -29y plus 32z equals -99. And that is my second equation. So now using those two equations, all I have here is a system like you would have dealt with in Algebra 1. So I'm going to take those. So -y plus z equals -3 and -29y plus 32z equals -99. And you can eliminate whichever variable you want here. It doesn't matter. I'm going to go ahead, let's eliminate z because that's, I don't know, just what I wanted to do there. So I'm going to multiply through by 2 to make that positive 32 cancel out. So that's going to give me 32y minus 32z equals 96, positive 96. And this one I'm going to leave alone. So this is going to give me 3y equals 0z and then that's 3. So now here I'm getting y equals 1. So boom, that's the start to what I need to solve for. Now, stay in this column, or stay in this lane if you're solving here. Go back to either one of these original equations and plug y back in. So negative y plus z equals negative 3. So that would give me z equals negative 2. And then you have y and you have z, so go back to your original. It doesn't matter which equation you pick, and plug in. I'm just going to do it into equation 2. So negative x minus 5 times 1 plus 6 times negative 2 equals negative 24. And from that I get out that x equals 7. So remember, you're going to write your coordinate as an xyz point. So 7, 1, negative 2. Again, if this is something you struggle with, and I'll link my first unit live stream in the box down below this video, but just go back to that and that's where we can start. Okay, let's go to some Unit 2 stuff. So Unit 2A, we're starting with laws of exponents, and this was something as we did stations in my class on Thursday and Friday, people had some questions about, but I tried to pick the most common mistakes that I normally see and use these as the explain the errors here. So we're going to zoom in on these, and we're going to take a look at each of these right after I grab a drink of this tea. If you have questions, guys, please continue to send them to me, okay? All right, so explain this error. All right, so what I see here is that I'm raising a power to a power, so I'm going to multiply. So this should become 5 to the negative third. Now, that's fine, but does 5 to the negative third equal negative 1 over 25, or sorry, negative 125? This is where a lot of people make their mistakes. A negative exponent just flips your base. It does not make your answer negative. So flipping my base, this would become 1 over positive 5 to the third. 5 stays positive. All that changes is the sign of the exponent. And that is 1 over 125. So what this person did was they thought the negative exponent would make the answer negative. But negative exponent should flip your answer. All right, let's look at this next one. So negative 2x to the negative third. So if I take a look at this, I want you guys to remember that negative 2 is really just to the first year. And the reason I would flip something is because it has a negative exponent. Negative 2 does not have a negative exponent here. So this is really just negative 2 to the first. X to the negative third, I could make 1 over x to the third. So this person flipped the 2 to the bottom because they got confused between a number being negative and the exponent being negative. A negative number doesn't need to flip. A negative number, it's just negative. An exponent negative means that it flips, okay? A negative exponent means that it flips. So this should be negative 2 over x to the third. And last one, on this one, again, I'm raising a power to a power. My best advice to you guys here would be to put this to the first, because what this person did was 2 times 3 instead of raising it to the third. So power to a power, you multiply the exponents. You don't just multiply whatever number you see. So this would be 2 to the third because it's 1 times 3, and this would be x to the 9th. So this would actually be 8x to the 9th. So those are really common mistakes that I tend to see here. Let's look at some of these simplifying, and we're not going to do all of these. We're going to pick maybe 2, and then we will go from there. But again, all of these, the solutions and everything, are on your or on my teacher site under the review key. So I'm going to start with A, and then we'll probably do D because I think that's the hardest one. So for A, I see that I've got powers to powers, and I see that I have some multiplying. So let's start with the power to a power. I see that this is negative z to the first, y to the negative third, 4 to the first, z to the 6th, y to the 9th. So let's do this. I've got negative z to the second, right? And so power to a power multiply, that's going to be z to the second. The reason I'm dropping the negative is because I'm squaring it, so the negative can go away. Then I've got y power to a power, so y to the negative 6th, times Now raise each of these to the negative second. 4 to the negative second, z to the negative 12th, y to the negative 18th. So what I have there is at least we don't have any more powers to powers, right? So now let's go through and deal with our like bases. 4 is not like any of those other bases, so I'm just going to leave that out in the front. And then we've got z and z. When you add your bases, multiply your exponents. Or I'm sorry, multiply your bases, add your exponents. So this is z to the negative 10th. And the y's, I've got negative 6th and negative 18th. So that is y to the negative 24th. Now each of those are to the negative power. So I'm going to flip them all to the denominator. So this would be 1 over 4 squared, z to the 10th, y to the 24th, and 4 squared is 16, so 1 over 16 z to the 10th, y to the 24th. All right, let's do one more of these. Let's go to D, because that one's kind of the big mama. So here I see multiplication in the numerator, no powers to powers. And I see multiplication and power to a power in the denominator. So let's kind of start off with the power to a power. So my numerator is going to stay the same. My denominator, this is going to stay 2a to the negative 3rd. This is going to become 5 to the 2nd, p to the negative 2nd. So that's just what I'm starting with, power to a power there. Now let's go through and deal with our numerator and our denominator separately. So 5 times 6, those are just numbers, just multiply them. A to the 2nd, p to the 3rd. You can't combine anything in those because they don't have like bases. And then down here, well, I have 2 times 5 squared. That's 50. 5 squared is 25. A to the negative 3rd, p to the negative 2nd. So let's go from there. So this would be 30 over 50 is 3/5. And that's a to the positive 3rd. I'm not sure why I wrote negative 3rd. A squared minus or over a to the 3rd, divide, so subtract. So that's a to the negative 1st. When you do that, your answer always goes to the numerator. And that's p to the 5th. And then I can just bring that negative exponent down. So 3p to the 5th over 5a. And that would be my answer. So again, if you need more help on those, go back to my Unit 2A live stream. Tons and tons and tons of practice on those. There's lots of videos on YouTube. You can go to Khan Academy and look at videos, but start with those. All right. I'm going to pause a second. If you have questions, send them, and then we'll go from there. Okay, let's look at this next one, and then we'll hop into some log stuff. So which of the following is not equivalent? So let's take a look at this. Now, not equivalent, remember, you could always plug in your calculator and just see which one doesn't match up. That will obviously work. But if this was a free response, or if you needed to explain, think about your exponent properties, right? So I'm going to start knowing laws of exponents that I need to deal with the exponent first. So I'm going to look at this thing right here, because remember, when you have exponents that have been multiplied, it means that you originally had a power to a power. So I actually already can tell you that D is equivalent, because instead of having 2 to the negative 2x, we broke it up as 2 to the negative 2 to the x. So I already know that that's equivalent. Now, 2 to the negative 2 is 1 over 2 to the positive 2. That means B is equivalent, because those are the exact same thing. And that is the same as 1 over 4, so C is equivalent. So what happened on this one was, instead of doing 2 to the negative 2nd, they did 2 times negative 2. So A would be the one that is not equivalent. But remember, you could put them in your calculator and look at which one doesn't match up. All right, let's take a look at some of these graphs, because these were things we were getting stuck on the quiz. Whether you were in my class or another teacher's class, a lot of teachers said to me, this is an area where kids were struggling because you guys were too quick to trust your calculator instead of trusting your mathematical knowledge. So let's start with this one. If you put this in your calculator and sketch it, you are going to get you should see that there's an asymptote at -6. And the way I know that, and I'm just going to show you guys my graph, is, it's a little hard to see, but there's my graph. And notice that's where it kind of approaches but doesn't hit. Now the other thing is, look at your transformations of functions here. If you actually look at this, this got slid down 6. So looking at that, knowing that it got moved down 6, that will be my asymptote. Since it crosses the y-axis there, it's y equals -6. Now, remember an asymptote is something that we approach but don't actually hit. I'm going to pick a couple other points. So 0, -3 was a point from my table, and 1, 3 was a point from my table. And other than that, I'm kind of just going to sketch this. So this is going to come up and go like that. And notice that it's approaching this line, but it's not actually hitting it. And that's really what your exponential graph should look like. Now, if I look at this going from left to right, thinking about domain, there is an arrow on that end. And I know your calculator won't show that, but you need to understand that about exponentials. And so my domain here is -infinity to +infinity. That is always your domain of an exponential function because there is no real number that you can't plug in to be an exponent. Now, the range here, typically for an exponential, it's from 0 to infinity. This got moved down 6, so this is going to go from -6 to infinity. And remember that we have a asymptote there, and we don't actually hit it. So it should be a parentheses. Now, transformations. That -6 was a translation down 6. This +1 in here, so it's going to be horizontal, and it's going to be going the opposite way. So this will go to the left 1. All right, let's look at a log. So this is what my graph looked like. I'm going to start by showing you guys that. That's what my graph looked like. And notice I drew in my asymptote right there. The reason that I knew where that was because typically the asymptote for a log is at 0. And when I look at these transformations, my sneeze went away. Okay. This moved to the right 6. And so that means my asymptote is also going to move to the right 6. So 1, 2, 3, 4, 5, 6. I know on your calculator it's not going to show that. So you guys need to be aware that there is a vertical asymptote there. And you need to be able to find it. And so remember, even if you see error on your calculator, it can still go right up to that asymptote. So that crosses the x-axis at 6, so my vertical asymptote is at x equals 6. Now, I know from looking at this crosses at 7, 0. That doesn't mean that my graph stops there. That means that that is the last kind of known integer point. So then that should continue down, approaching that. So domain, again, normally it's from 0 to infinity. This got moved to the right 6. So this would go 6 to infinity. And the range is -infinity to +infinity because, remember, this is the inverse of an exponential, and you can always get out that answer from a log. Formations, we said this moved to the right 6, and then that +1 would move it up 1. Make sure that you look at those asymptotes, which one is x equals, which one is y equals. The easiest way to tell is look at which axis it crosses. The y equals crosses the y-axis at that point. The x equals crosses the x-axis at that point. So that's really the easiest way to tell there. All right, converting. This is by far the most important skill you will use in this unit. You guys are very, very good at this, at least in my class. I've seen huge strides in this. I've seen you guys doing an awesome job with it. But make sure that you can convert reliably because it's definitely something that you're going to need to do. I'm so sorry, guys. Doing this when you're sick is the worst. So we're going to convert a couple of these. Again, if you get it, great. We're not going to spend a ton of time on this, but we're going to do a couple. I know some teachers have you do like the BEN thing. Some teachers have you draw certain symbols. There's different ways to convert these, but I'm just going to do some general converting. Whatever trick that you use to remember that is fine. So I'm going to start with this one. So what I always ask is sort of, okay, I know that I'm going to have something equals log base something of something. That's sort of what I know my setup is. So first thing I would say is, in this exponential, what's my base? Well, my base of the exponent is 5, so log base 5. Remember that logs are exponents, so this should always equal your exponent. And then this answer is what goes in there. That's your argument. Because remember, this is saying what power of 5 equals that. So it's literally saying 5 to the what is this. And so your answer should always be that -3. Again, different teachers use different tricks, but that's where I would start. All right, let's do a couple log ones. So here I've got t equals log base 4 of 7. So again, I think like I've got something to a power equals something. And remember what this is saying? This is saying what power of 4 is 7. So 4 to what power is 7. Now, you can convert this in a lot of different ways. You can also do like the circle trick, 4 to the t equals 7. But just make sure that you reliably know how to convert those. Now, 2 that you might see might be a log with no base. Remember that there's an assumed 10. 10 to that power equals 7. And lastly, ln, remember that's just log base e, so e to the k equals q. More practice on that on your review sheet. Okay, let's solve some equations. We'll do a couple word problems, and we will be out of here for the night. So, solving equations, what I always tell my kids is, identify whether it's a log or an exponential, right? Does it have a log or not? And then put a rectangle around either your log or your exponential part, because that's what we're going to want to isolate. So if I look at this first one, the exponential part here, there's no log, is the base and the power, and that's it. So this, I'm going to put a little rectangle around, and I need to isolate that. Well, that's being multiplied by 50, so I'm going to divide both sides by 50. So 2 would equal 0.5 to the x. Now, this is isolated now. Once it's isolated, convert. So then I could say log base 0.5 of 2 equals x, or x equals that. And so from there, you can plug that into your calculator, or you could say what power of a half is 2, and remember that that would have to be -1. Okay, same thing for this one. So I'm going to look at this and say, okay, this is a log base argument. That's the whole log. It's already isolated, so then I can convert. So my base is 3, my power is 2, and then that would be x minus 1. And now just solve it for x. So add 1 to both sides. 3 squared I can easily figure out, just 9. So x equals 10. Now remember, with any log equation, you need to plug this back in and make sure it doesn't yield a negative inside your parentheses there, or a negative argument. This one doesn't. Log base 3 of 9 is 2, but remember that we can get extraneous solutions, and so you need to be very careful with that. All right, one more of these, maybe 2. So this is my log base e of x minus 3. It is not isolated. That 2's got to go. So divide both sides by 2. So ln x minus 3 equals 4. And then it's isolated, so we can convert. So e to the 4th equals x minus 3. And I didn't actually divide by 2. That would be helpful if I did that. So this would be e to the 2nd. And then add 3 to both sides. So e squared plus 3. Now, if it said to round, you could plug that in your calculator. This did not, so I would leave it like that. That's exact form. All right, last one. So this is exponential. This is my exponential, so I need to isolate that. So 16 equals 2 to the 2x. Now, you could convert this and solve, and I saw some people who said, oh, I see I could get these bases to my would equal 2 to the 2x. 4 would equal 2x, so x would equal 2. But you could also, at this point, convert to log form and solve, so more than one way there. All right, we're going to do a couple of these. We're not going to do all of them, But at least with the setting up, these are ones where we need to make sure we still understand our exponential models because those are important. So, take a second and read this one while I go blow my nose. I'm sorry. I'll be right back. Okay. Crisis averted. Sorry. So, Jim opens a savings account where interest is compounded annually. That should be making you think of y equals a 1 plus r to the t. And $1,500 was deposited in 2001 at a rate of 5%. What's the first year the account will be worth $3,000? So let's set this up. So I want to know when it will equal $3,000. The initial was $1,500. 1 plus 0.05 to the t. So that's how I would set that up. So now let's simplify what we can. Let's go in those parentheses. And then this is your exponential part. So we need to isolate that. So divide both sides by 1,500. 2 equals 1.05 to the t. Now it's isolated, so log base 1.05 of 2 equals t. And that's going to shoot you out 14.20669908. Now that's the 4, right? So if I started in 2001, this would be in 2015. All right, this next one. How long will it take 5,300 to become 7,000 if it's invested at 9% and is compounded quarterly? So quarterly should make you think of this formula. Y equals A 1 plus R over N to the NT, where N is the number of times per year. So it's going to be 7,000 equals 5,300, 1 plus 0.09 over 4 to the 4t. And then we're going to start solving from there. So I would simplify what's in parentheses, which is 1.0225 to the 4t. Divide both sides, and this doesn't divide evenly, so what I would do is just leave it reduced. So 70 over 53 is 1.0225 to the 4t. Convert, so 4t equals log base 1.0225 to the 70 over 53. And then divide both sides by 4. And so that gives me 3.125794549 years. And we will tell you what to round to on the test if we want. All right, these next couple we're going to set up but not solve because then I want to get to kind of the big mama type of problems, which were those ones where we have to solve for a constant and then go from there. Okay, so if we do that, let's look at this. A radioactive material is decaying according to this formula, where A is the final amount, A0 or A sub 0 is the initial amount, and T is in years. And it wants us to find K, but it tells us that this much decays to be 550 in 8 years. So what it's giving us here is initial amount, final amount, and T. And if I'm trying to solve for K, I need to plug in for everything but K. So this would be 700 not E, 10, to the negative K times 8 equals 550. And then from there, we can solve that. So divide both sides by 700 and then convert and solve. The key to that is on your review sheet, so check that there. All right, so Lucy is investing $6,000. It's going 6% continuously. Continuously should automatically make you think PERT. How long will it take to reach 25,000? So I want to know when it will equal 25,000. my initial is 6,000 e to the 0.06 t. And again, divide, convert. Okay, so let's do some where we need to figure out this K thing. So, the concentration of alcohol in a person's blood is measured. Medical research suggests that the percent of getting in an accident can be modeled by this equation. X is the concentration of alcohol in the blood, and K is a constant. So, one says, suppose that a concentration of alcohol results in a 0.04 results in 10% risk. And it tells you to use R as 10 of the accident, find K. So again, if you're trying to find K, remember you need to know every variable but K. So it tells you R should be 10. And that would equal 6e to the K times X. And it tells me X is concentration. So this is 0.04. This is a time where your variable of X there is not time. So make sure you're mindful of that as you're going forward. Now, this is just like every other problem we've done. This is your exponential. So isolate that. We're going to divide 10 by 6. So that would be 5/3 equals e to the 0.04k. Now convert that. So 0.04 equals ln of 5/3. And I'm sorry, that would be a k on that side too. And then divide by 0.04. This would be ln 5/3 over 0.04. If it said exact form, you could leave it like that. If it said to round, then plug in and round. So that's your value for K. Now it says using K, what is the risk if the concentration is 0.17? This is your concentration, so that's X. So now it's saying, okay, figure out R if we know that that's our concentration. So K is that number, ln of 5/3 over 0.04 times 0.17. And that's a very high level of blood alcohol content. So the risk there comes out to be 52.602748441%. So more than 50% chance there that you're going to get into a car accident. What concentration will correspond with 100% risk? So I'm going to do 100% equals 6e to that k that I found before, x, because it wants a concentration, divide both sides by 6, so that would give me 50/3 is e to that power. Convert, and you are going to get that x equals 0.22203030022. So our best estimate here is that if that concentration is in your blood, there's a 100% risk that you would get into an accident. Again, our best estimate. Now it said, assuming that if there's anyone with a greater risk than 20%, what should be the limit that we should have? So what I would do again is set this equal to 20, and let's see what that concentration should be. So I'm going to solve this in the same way. Divide both sides by 6, convert and solve, and I wind up getting that x is 0.0942766618. So that would correspond to a 20% chance. Now, if you know the legal limit for driving is 0.08, you always see like 0.08, don't blow it. So 0.09 is a 20% chance, 0.08 would be the limit just below that. So there's a lot of math that actually goes into some of what you see, especially with insurance companies. And if you ever think about becoming an actuary, there's a lot of math that goes into this risk assessment, and logarithms can sometimes be helpful with that. Last one, Newton's law of cooling. So a brewing pot is 200. The temperature in the room is 70. After 8 minutes, the temperature is 143. A says find the exponential equation to represent this. So that means I need to find K. And B says how long will it take to reach 158. So let's see what we remember. This is our final temperature. And again, I would always tell you these on your review sheet. It tells you them. I just forgot to put it on this live stream. TS is the ambient temperature, which is the temperature of the surrounding area. This is your initial. K is a constant, T is time. So let's see what we know here to figure out K. So I know that my initial is 200, room temp is 70, and this is my final. So I would set up that 143 equals the ambient temperature plus the initial minus the ambient, e to the negative k times 8, because it's after 8 minutes. So that's my setup to find k here. So I'm going to subtract 70 from both. Well, first I can simplify this. 70 plus 130 e to the negative 8k. And this is my exponential, so I need to get that alone. So I'm going to start by subtracting 70, so that would give me 73 is 130 e to the negative 8k. Divide by both sides by 130. And now, so then we can convert and then divide by negative 8. So negative 8k equals ln of 73 over 130. Divide both sides by negative 8. And so this would be your constant. And try not to sneeze. Okay. Sorry, guys. So my equation here would be T of T equals, and then sub in everything that we know. We know it's 70 plus 200 minus 70, which you could leave that way, or you could put as 130. E to the negative, k is this, so ln 73 over 130 over negative 8t. And some people put that as a decimal because they just didn't round it. That's okay. How long will it take to reach 158? So set that equal to 158. And then you could 70 divide by 130 and then divide by your k. So that is all that I have planned for you guys. I'm going to hang out for a couple minutes for questions. Again, I'm really sorry that I'm sick and kept sneezing and having to blow my nose. But thanks for bearing with me. I hope that this was helpful. And again, if you have questions, send them. And if not, good luck on your quarterlies. And I will see you guys in our next live stream. All right, looks like I will talk to you guys later.